We will see a demo video where we will do the analysis and design of a combined footing using MMS programs. So let's go to design section, program list. This is the program for doing the analysis and design of a combined footing. Over here we are taking an inverted T-beam on which the two columns are supported. Okay, usually in practical field, when the individual footing of two different columns overlap with each other, then we have to go for an alternate combined footing. In this case, you can design a combined footing which can have two columns. Okay, this is the inverted T-beam. Okay, now we will see how can we run this program using MMS programs. Say the number of member is 1. Okay, press enter key to store the data in the text box. Press enter. F5 is 415, CK is 20, SPC is 150 kilonewton meter square. Right, press enter. Now length of footing axle. So in case of the practically you can always assume a total length of the combined footing as according to the site condition. Say the available length for the combined footing is 6 meters on site. So axle, this total length of the footing axle 6 meters. Right, press enter. Write the depth of column T1. This is column T1, this is depth. This is column T2, column 2, this is column 1 whose depth is T1, this is column 2 whose depth is T2, and the width of this column is W1 and the width of this column is W2. Okay, and this is the beam. Okay, this is the beam and this are the flanges of the T section. Right, so T1, we are assuming that both the columns are of 450 mm by 450 mm. So T1 is 450 mm, that is 450 mm. T2 is again 450 mm. Press enter. And W1, width of column 1 is again 450 mm because we are taking square column 450 mm. And width W2 for column 2 is again 450 mm. Okay, now we have to assume a width of beam. So this width is 450, then this has to be at least 75 mm and 75 mm greater than this, at least. Okay, so 75 plus 75, that is 150 plus 450. So let us assume the width of the beam to be 600 mm. 600 mm. Right, press enter. Now give the distance from the left end to the center of column 1 in meter, that is x. Okay, so this is x, so x is 1 meter. Okay, center to center distance between column 1 and column 2, that is y. Okay, y, so this is 4 meters. Okay, now load, point load and moment to be given below must be factored load and factored moment. Let us assume that the point load on this column is 1000 kilonewton factored load. Okay, press enter. Point load on column 2 is at 1200 kilonewton. Okay, press enter. Now moment on column 1 about the width. Right, so that is in this direction. Right, so say this column is 100 kilonewton meter. Okay, clockwise is positive, right, press enter. And the moment on column 1 about depth, that is in the perpendicular direction. Okay, So say that is 0. Okay. Similarly, the moment on column 2, uh, this over here is 100 kilonewton meter in clockwise direction. So we are taking it as positive. Okay. And this moment is again say 0. Press enter. Now, as all the data has been given, let us click finish. Are there any further editing to be done? Uh, are you sure no further editing is to be done? Yes, we don't want to do any further editing. Okay. Now, this page selects the load factor. Okay. If you select this option, then the load factor will be taken as 1.5. If you select this option, then the load factor will be taken as 1.2. And if you see, and if you want to give some another load factor, then you can I use this and option and give it from the screen, right? But we know that the load factor we have used is 1.5. So let us select this option and click finish. Okay, so we can see that the analysis of the footing has been completed. Okay, so we can see over here in this table that from left to right, okay, and with a variation of zero point 0.1 meters from left to right, okay, the bending moment and shear force and the corresponding steel is shown over here. Okay, so there are all other details are also shown over here. Okay, if the depth of the web of the beam exceeds 750 mm, okay, then you have to provide face bars and all that. Okay, so this is how you can do the analysis and design of a combined footing using MMS program. Thank you.